Hey guys, we're getting into some function notation stuff. So here's your note guide to go along with it. Example 1. Evaluate functions in function notation. And how can you represent a function rule? So if we are writing the equation and there's going to be a fill in the blank, let's say we're writing y equals 5x plus 1. That's our equation, and I'm going to show you how to write it using function notation. Remember that a function is a rule that takes, a function is a rule that takes an input or an element in the domain. So remember, input is the domain, right? Any element in the domain, and maps it to an output or an element in the range. So here's a fancy little diagram that we're looking at. You've got the element in the domain, whatever that x value is. If you put it into this like function machine, and if it's 5x plus 1, it's going to output this f of x. That's how that's pronounced. It looks like f times x. That's f of x, which all it means is a function of x. The f is the function, and x is the domain that you're using, the input value that you're using. So what we're looking at here is continuing through our definitions. We've got blank is a method. So function notation, that's our vocabulary term that we're working on. So I would underline that and highlight it. Is a method for writing variables that's a function of other variables. The variable y becomes a function of x, meaning the variable x is used to find the value of y. This helps distinguish between different functions and the relationship between the variables. So you're gonna see things like f of x, g of x, h of x, all these different variables that represent y, right? All of them. So the function f is defined by function notation by, so instead of y equals, like we had up here, y equals 5x plus 1, only thing replaced because it's function f is f of x equals that same function. Okay. All right. So part B to what we are doing, we've got the question, what is the value of g of x when x equals 3? All that means is you're plugging in 3 into your equation and you should get a certain output. So if you do 5 times 3 plus 1, that is 15 plus 1, 16. And if you notice, it stays as g of 3 means the value of function g, so the name has changed now from f to function g when x equals 3. I have 2 questions for you to try, and then we can practice after. Evaluate each function for x equals 4. So pause the video and do that, and then let's look at example 2. Example 2, so now we're going to write a linear function rule. The cost to make 4 bracelets is shown in the table. How can you determine the cost to make any number of bracelets? So I've got, if there's 1 bracelet, 17, 2 bracelets, 32, and so on and so forth. So the first thing you got to do is look at that slope, that rate of change. Well, the number of bracelets from 1 to 2 to 3 to 4 is being added by 1. And the cost is going up by $15. If the rate is constant, the relationship is linear. The slope, you see, is change in y over change in x. So 15 is my change of y, it's the cost, and 1 is the y, so my slope is 15 over 1. My rate of change is 15 for that reason. And then you see the constant rate right over here of change is 15. So that's step 1. Find your rate of change. Then let's use slope-intercept form, but instead we're going to use function notation. So instead of y, we have f of x, and that equals mx plus b. So I replace my m with my slope that I just figured it out, which is 15. And now I got to find the value of b, just like we've been doing, right? Substitute any ordered pair from the table. So they picked the very first value, 117, or I picked whatever. And if you solve it, 17 is your y, or your f of x, equals m is your slope, that's your 15, times that 1, that's that x value, plus your b. So that's 17 equals 15 plus b. Subtract 15 from both sides, and your b value is 2. So you know your slope, you know your y-intercept, so all you gotta do is write it, but changing that y for f of x, don't forget. So f of x equals mx plus b, 15x plus 2. So that means that if we go all the way to the beginning, the cost to make 4 bracelets is shown. So these are the costs. So it's $2 to start and then $15 for every bracelet. And then work on this, try it, write a linear function for the data in the table using function notation. So just like we just did, pause that video and try this problem. And now we have example 3. And example 3, we have a graph, and you need to write a function rule when given a graph. So no different. We've already did this, but the only difference is your y-intercept is really like your function of x-intercept, whatever. So typically they tell you what the function is. So this could be for function m of x, right? So function m, which means, so we still find our slopes. You got to look and see where you can rise and where you can run. I could see at -1, I've got a point. And then at 2, 2, I've got a point. So my slope, I rise 1, 2, 3, run 1. So my slope is, I should change this function to function f. Keep it simple, since there's already an m here. My slope is 3/1, which is 3. And then my y-intercept is clear in this graph. It's -4. So I know my b value, my b, I hate how it does that. B, okay, ignore that. B then equals -4. So I'm writing my equation. I'm remembering to use the function notation. So f of x or g of x, whatever it happens to be. So f of x for this one equals 3x minus 4. And that's my answer. Feel free to write it anywhere, right? Okay, almost there. Example 3, didn't we just do that? So this is really example 4, sorry. Tamika records an outside temperature at 6 a.m. The temperature increases by 2 degrees Fahrenheit every hour for the next 6 hours. If the temperature continues to increase at the same rate, what will the temperature be at 2 p.m.? So this is the temperature at 6 a.m. So my starting value is -3. And it increases by 2 every hour. So that's my slope. And it says write a function that models the situation. So f of x, lowercase f, equals 2x minus 3. My starting value, so just like we did up there, starting value is that -3. I see it in the picture, and my slope increases 2 every hour. On the next page, it says to graph it. Well, hey, look, you know, I already graphed it for you. Start at -3, rise 2, run 1, rise 2, run 1. There's your graph. Now, step 3, sometimes it's going to say, well, what is the value of y when x equals 8? So what we're doing here is we're plugging it in right into the equation. So, sorry, bear with me. So if we see this equation, I'm just pulling it over. If we see this equation, we're plugging in, it's 2x minus 3, so we're plugging in 8 for x. 2 times 8 is 16, minus 3 is 13. So that's what I'm going to include right here. So 2 times 8 minus 3. You can just write on top. And that equals 13. And then the second part says, assuming the temperature continues to increase at the same rate, the temperature at 2 p.m. will be 13 degrees. That's answering this question. Find the value of y when x equals 8. So at 2 p.m., 8 hours from the start time of 6 a.m., right? 7, 8, 9, 10, 11, 12, 1, 2, 8 hours. Back it up. 8 hours later, so that's why an 8 went in. And then it will be 13 degrees. So the graph of y equals 2x minus 3 is a line. A linear function is a function whose graph is a line. So that's where you're filling in this part. Y equals 2x minus 3 is a line. A linear function is a function whose graph is a line. Okay? The second part, we need to start talking about reasonable domains. We've already kind of talked about it. So since Tomiko is talking about temperature within a given day, one day, the domain should be represented by 0 being the smallest value and 24 being the greatest value. So the way to write that is by something like this, where it shows the starting to the ending for x being because domain is x. And then for some of us who have been starting to do interval notation, because it can be equal to 0 and at max 24 but equal to it, you have those brackets. This is more what I expect, but we have seen it on the Pearson site to look like this. All right, last thing to do, I want you to sketch the graph of the function. So just think about your y-intercept and your slope, plot it. It's no different because this is your y. All right, fabulous.